You are about to see substances that behave as if you were in a science fiction movie. Take a look at this. This. And this. Although, this one really is from a movie. But this is certainly no trick. And, as always, we have prepared all the most interesting stuff for those who watch the video to the end. Let's begin with an unusual polymer called Terminator. If you remember the plot of Terminator 2, it should be clear to you why this substance is called that. The polymer can become whole again after it is divided into several parts. Another material, self-healing plastic, has similar properties. Once it is placed in room temperature conditions, the broken atomic bonds become restored. This happens 97% of the time. These miracles are created by the aromatic sulfides that make up such plastic. And here's another magical material, Vantablack. It is the blackest substance on Earth. This unusual substance consists of vertically oriented arrays of carbon nanotubes. These tubes are grown artificially on aluminum foil at low temperatures. They are so tightly packed together that they reflect only a tiny 0.035% of the light, and they absorb 99.965% of the incident radiation. That's what makes Vantablack so black. Because of this property, we perceive this material as if it were just a black spot superimposed in a video editor. An object made from it seems to have no volume. Instead of it, we see a mysterious dark hole or just a black spot. We won't see any wrinkles on this super black matter either. Even if the material is strongly crumpled, the human eye will not perceive it. Another unique thing is Line X. It is paint that makes things more durable. Line X creates long polymers that bond to the surface of an object to form a dense layer of plastic. Take a look at these ordinary plastic cups. After they are covered with Line X, they can withstand even the weight of such a huge guy. Graphene is the most durable material on Earth. It is 300 times stronger than steel. A sheet of graphene with an area of 40 square inches and only 1 atom thick is capable of holding an object weighing 9 pounds. Graphene can be folded, rolled, and stretched like a napkin. Carbon has many allotropes. Some of them, for example, diamond and graphite, have been known for a long time, while others were discovered rather recently, from 10 to 15 years ago. It should be noted that graphite, known for many decades, is basically a stack of graphene sheets. That is, it contains several planes of graphene. Graphene was found by Konstantin Novoselov and Andrei Geim, who work at the University of Manchester, for which Russian scientists were awarded the Nobel Prize. They got it very simply, by peeling off ordinary graphite with duct tape until they had a layer only 1 atom thick. Next on our list is a mysterious material called Starlight. To be short, the egg covered with Starlight turned out to remain whole and liquid even after it was heated to a temperature of 2,700 degrees. Later, a NASA spokesman confirmed that Starlight is not a fake and has unlimited utility possibilities. Unfortunately, it didn't go into mass use because the inventor owned exclusive rights to the material and took the secret of manufacturing it with him to the grave in 2011. There is also a special class of materials called aerogels. Basically, it is a gel in which the liquid phase is completely replaced by the gaseous phase. It is often called frozen gas. While being solid, aerogel can be 99.8% air. Nevertheless, this material is super strong. It can support 4,000 times its own weight. This extraordinary substance was invented by the American chemist Stephen Kistler. Just imagine, back in 1931, almost 90 years ago, he published the results of his first startling experiments in Nature magazine. Later, in the 60s, aerogels were discussed more actively. With its extremely low density, aerogel has super low thermal conductivity. It is also very light. 150 brick-sized blocks weigh like a gallon of water. Aerogel also has unique super insulating properties. For example, this thin layer can protect a flower from open flames. The most extensive field of application for aerogel is space. It is actively used by aerospace agencies as a thermal insulator. And here is another material that also likes warmth. Nitinol or titanium nicolide is an alloy of nickel and titanium with very unusual properties. This substance is able to remember its original shape and return to it after deformation. The effect is achieved by heating the alloy to a temperature of 1,200 degrees Fahrenheit. The material is given the necessary shape, while its molecular lattice remembers its structure. Even if the lattice is deformed, it returns to its original state. For this, the nitinol has to be heated to about 122 degrees Fahrenheit. This broken paperclip became whole again after it was placed on the burner of an electric stove. Or this wire, which returned to its previous shape after being placed in warm water. The heating temperature depends on the grade of the alloy. For example, these sunglasses can be bent in any shape at low temperatures, but they will regain their shape at room temperature. Another substance that couldn't care less about the laws of physics is ferromagnetic liquid. It was created in 1963 by NASA employee Steve Papell. The scientist had to solve an important problem: how to make the liquid in the spacecraft fuel tank get close to the port from which the pump was pumping fuel into the combustion chamber. So, Papell came up with the idea to add some magnetic substance to the liquid. Ferromagnetic fluid consists of ultrafine magnetic particles, usually iron. When a liquid is exposed to a magnetic field, it begins to make bizarre dance moves and form extraordinary structures. They are called ferrofluids. Each particle is coated with a surfactant that prevents them from sticking together. Basically, ferromagnetic fluid is a colloidal solution, a substance that combines the properties of more than one state of matter. In this case, of liquid and solid metal, ferromagnetic fluid has a very low coefficient of friction in contact with a solid body. It can also penetrate very small objects and wet almost any surface. Gallium is a metal that liquefies at 84 degrees Fahrenheit. That is, if you hold it in your hand for a few seconds, you will find a warm puddle in your palm. It is also surprising that if you put a piece of gallium in a glass of hot liquid, it will dissolve right before your eyes. Another property of gallium is its special effect on aluminum. In contact with gallium, it becomes extremely fragile and brittle. But there is also a benefit from gallium. Sometimes, it is used in thermometers. Helium II. Helium in itself is already unique. It is the only gas that liquefies at the lowest temperature of -450 degrees. Moreover, upon further cooling, it retains a liquid state, although all other substances on Earth become solid. But that's not all. In 1937, the famous Russian scientist Pyotr Kapitsa conducted several interesting experiments. They showed that liquid helium acquires the ability to flow without any friction at temperatures below -455 degrees Fahrenheit. This phenomenon was called superfluidity. For example, if you take a microscopic opening, to pass through which water will need many years, helium will do it in a matter of seconds. This amazing substance is called Helium II. Another superpower of Helium II is the ability to very quickly form a slick on a solid surface. Slicks of any ordinary liquid are very thin and slowly spread over the surface due to their strong viscosity. Helium has no viscosity at all, so this process is hundreds of times faster. The approximate speed is 8 inches per second. Now have a look at a substance called supercooled rubidium. It violates the laws of physics most vividly, and specifically Newton's second law of motion. For example, if you push a door forward, it will move forward. But what happens to supercooled rubidium? When cooled to absolute zero, rubidium behaves like a substance with negative mass. If you apply force to it, it will begin to move in the direction opposite to this force, which is contrary to Newton's law. Do you know what is the most amazing substance that no one has ever touched so far? It's ether. Before Einstein's era, ether was considered a physical phenomenon. For example, Nikola Tesla saw great potential in ether. Its existence was proven in Dayton Miller's experiments back in the 1930s. The American scientist experimentally recorded the ethereal wind of light waves, which made the Michelson-Morley experiments invalid. They sort of proved the constancy of the speed of light, on which Einstein's theory is based. Miller wrote to Einstein about the results of his 24-year work, which confirmed the presence of the etheric wind. Therefore, the existence of ether. But Einstein ignored this information because it went against his ideas. So, it is not surprising that after Miller's death, his work never appeared in any scientific sources. And this is all for today. Which of the materials in this video would you like to experiment with at home? Write in the comments and rate the video if you think that the topic was worth our endeavors. Customize your notifications, and see you in the next video, which will definitely surprise you.